almost recording. Sine and cosine rules, we are recording now. So choosing the correct rule to use is actually a skill in itself. Some of you, I can see from past lessons, have already worked out a strategy for working out which rule do you use. A little clue is the ones you get in your formula booklet are this one. Are there any others that you know you get in your formula booklet?
Did you get all of them in your formula booklet?
Not all of them.
You only got that
Every
one,
except for one.
The bottom one, right?
This one?
No.
That one?
Yeah.
Now which one?
No, the top right.
Top right?
This
We definitely do get this one, yeah?
Yeah.
You think that one? So a clue is you either get that one or that one. Which one? Which version is in your formula booklet? Is it? I can't remember.
Yeah.
For sure? 100%. Oh, you have it there, do you, Sarah?
Yeah.
So Sarah's just checking. See how Sarah's checking, because I snipped the formula booklet and put it into the front of your in the booklet. So they're the ones you get in the formula booklet.
What's the difference between that one?
Maybe
I mean, like, I know the difference.
Yes, Sarah's just asked a good question. Are you asking, Sarah, what's the difference between that one and that one?
I see the difference, but I don't understand
How it's actually possible? Okay, so can anyone see a relationship between this one
Yeah.
and that one?
They're just swapped.
Yeah, they're just flipped upside down. Yeah, so because so sine A over A equals sine B over B plus sine C over C. With ratios, you just flip everything. You can't just flip one thing, one part of the fraction. As long as you flip both part of the fractions, then they're equal. I can show you a little proof that I'll just get rid of soon. So let's see, 1 over x. I don't know if this is proving anything at all. 3 over a. It's probably not proving anything for you. So if 1 divided by x equals 3 over a, then x divided by 1 equals 8 over 3. I don't think that's proving anything, is it? But I'll show you that it's the same thing, like if you solve for x, both of the ways. Yeah, you'll get the same answer for x. So if we cross multiply these two, you would get 3x equals a. So x equals a divided by 3. Same thing as this, 3x equals a, so x equals a divided by 3. That was just one attempt to show you that so long as you flip both sides of the fraction, then they are still equal.
No.
Oh, sorry.
I
can undo it.
I knew it.
Yeah. Yeah, that was just sort of to prove that this thing formally, so long as you flip all the numerators with all the denominators, then they are the same. Because see, you solve it, you still get 3x equals a, 3x equals a. Just getting rid of them. So one thing I want you to decide on, so these are the three, so that's why these are the three you get in your formula booklet. I just wanted to point out that it's possible, if you've got that, flip it all upside down and you'll have the other version. Okay, so, so which of the two sine rules, which one would you think would be easier to use if you're solving for a length, an unknown length? Which one of the two versions of the sine rule?
That one that you just talked.
This one? Yeah, why this one? I would say yes.
I don't know. Well, could they make it just like that?
Yeah. I tend to think, this is me, I tend to think if the thing you're looking for is in the numerator,
Yeah.
it's much easier. Because as Bella said, all then you need to do is multiply by sine A. Yeah. Yeah. If you're a big fan of cross multiply, then both are just as easy. But I personally find having the thing you want in the numerator, I personally find that a bit easier. So I tend to use this one. It's fine if you want to just look at that one, and you could always easily solve by cross multiplying anyway. But for this one to get the length, all you then have to do is multiply both sides by sine B, sine A, sorry. So sine rule, I tend to call this one sine rule for a length, is my little nickname for it. So just so you understand what I'm going on about, I tend to call this one sine rule for a length. By a similar kind of logic, what could we call this other one over here?
Sine rule for an angle.
Yeah, sine rule for an angle. I tend to find putting the subject in the numerator a lot easier. That's just me. Like I find this one easier to find length, this one easier to find angle. Sine rule for an angle is what I tend to use this one for, this version of it for. So to find A by itself, what would you have to do to deal with this thing? multiply it, yep, and then
Sine negative
good, yeah, sine -1. So that's a
Multiply
good,
of A.
yeah, not to get A by itself, angle A, we need to multiply both sides by A. Yeah. Multiply both sides by A, and then you would have sine A. So to get angle A by itself, you have to do sine -1.
Yeah. So that means it'll end up being A sine B over AB for that side.
Yeah, good. So you get A sine B, or A sine B over little b, but to get the sine -1,
But what about the A then? Isn't it? Oh, because A over 1.
sine -1. Yeah, so we tend to multiply both sides by A to begin with, and then to deal with the sine, you can sine -1, all of that. That's kind of the transformed version, the rearranged version of it.
But I want to write that.
Yeah. There you go, yeah. So the transformed version, A equals sine -1 of A sine B over B. But again, that's hard. It's just, you don't need to memorize that. You just need to be able to transform this into the, it's just what we need to do. In terms of the cosine rule, cosine rule, and of course, actually, yeah, maybe we can do the more transformed. I'll scroll down a bit so we can do the bottom one transformed. So this one down here, we can use some space to do that. If you were to transpose the one down here and make it A equals, notice that I'm just kind of dealing with this first two. I'm kind of pretending that one's not there, so just pass it out there. So Bella already mentioned what you would need to do. Bella, what did you mention you need to do to get A by itself? Yeah, so that's a nice easy one. So that transformed would be A equals B sine A over sine B. So I'm going to calibrate again. So B sine A over sine B. In terms of the cosine rule, which of the two versions of the cosine rule do you think is a bit easier for length?
The one in the bottom.
Yeah,
Yeah, why that one?
No one equals the length.
Yeah, it equals the length. If I just type b squared plus c squared minus 2bc cos A into a calculator, would I get the answer for A? Or should I do one little extra thing?
You should square root it.
Yeah, square root, yeah. So if you're like me, you might forget to do that. So I tend to go straight to square rooting it when I actually do use it. That's my little way of avoiding forgetting. That's my little way of forgetting, making sure I don't forget to square root the answer. So this one we tend to do cos rule for a length. I tend to call it cosine rule for a length. Cosine rule for a length. Cosine rule for the length. So what if I just typed, for the cosine rule for an angle, what if I just typed in b squared plus c squared minus a squared over 2bc? Have I got the answer? No! What should I do first, Bella?
Cos -1.
Yeah, exactly. So same thing. To avoid, by accident, finding a squared, we square. I tend to square root straight away. Like, or at least have the square root over all my numbers subbed in, like that. And then to get A, I tend to go straight to cos -1. Open up a big bracket, because then you have to put in all the details in the big bracket. B squared plus c squared. Sorry, the calibration's really bad on the board again. That's why it's interesting.
I'm surprised you haven't asked for us to move rooms.
Yeah. I should have a look around and see what other rooms are being used, and do those features right on the board much.
Wait,
If they just need a projector, then it could be in here.
We have math 3 times at what we have dinner.
Yeah. I was hoping this one might get better with time. Rightio. And the thing is, it'll be calibrated, and then, like, within a few minutes, it's gone again for some reason. I'm not sure why. Okay, so sine rule for a length. So in general, I think Kieji, you might have mentioned this. You use the sine rule when you're dealing with two and the two opposites. What on earth was I going on about with that?
It just bothers me because look how the A is not on the line.
when you're dealing with two angles and they're two opposite sides. Let me give you an example of one like that. That would be the sine rule one. So we might say this angle here is 30. We're making up a nonsense thing here. And maybe we say its opposite side is x. And similarly, I might say this angle here is 110 degrees, and its opposite angle is 4 centimeters. So that's an example of a sine rule one. If you're having trouble reading that, that's fair enough, because the writing's all over the place. So notice I've got side, opposite angle, and the unknowns within that as well.
What's the unknown? X.
Yeah. Similarly, I could do another one. I'll draw another one just to show you it can be with an angle as well. I'll draw this one a bit bigger. You could have an unknown angle, theta, and an opposite side, 17 meters, and an angle 29 degrees, and opposite side, the opposite side, something like 10 meters. Just making up some numbers there. Just pointing out what it would look like. We have a side, opposite angle, side, opposite angle. Side, opposite angle, side, opposite angle. And the unknown's included in that. So if they haven't written in the unknown for you, maybe label it x. If it's a side, maybe label it x. For example, if it's an angle, label it theta. That helps to enable you to see that it's a sine rule. So side, opposite angle, side, opposite angle. Whereas you use the cosine rule more so when you're dealing with 3 s and 1 a. It's pretty obvious by now, isn't it? 3 sides. So that's the difference. It's not 2 sides and they're opposite angles. When you're dealing with 3 sides and 1 angle, that's when we tend to use the cosine rule. So then I've got some examples, and I want you to pick. Oh, I was meant to say, which rule to use. So here's 2 examples, and I want you to work out which rule do we use. So for the first one, do we have side, opposite angle, side, opposite angle?
Sorry, I was getting no.
No. Katie, what would you use for this one? Good guess? Yeah, why cosine? Yeah, you're dealing with 3 sides and an angle. So cosine rule for a side or an angle? Yeah, exactly, because we're trying to find the missing side. Yeah, because we have 3 sides and an angle. Notice that what must happen is the unknown side must be opposite the angle that you're putting in the cosine rule. So the unknown side must be opposite the angle that you're putting in there. If you know the other 2 angles, you'd have to find the other angle. So 3 sides and an angle, the unknown side must be opposite the angle you put in the formula. So sometimes people call they call it angle A, so side A has to be the unknown.
Why do you put cosine rule for each side?
Yeah, for a length, yeah. If that makes sense. As in
we're trying to figure out a length, right?
Yeah.
Because it has x, so we're trying to figure out what x is, so that's a side.
Yeah. So by cosine rule for a side, I mean this one, like a squared. Gosh.
I get it.
Yeah, not the cos a one, but a squared equals b squared plus c squared minus 2bc cos a. That one. Whereas with the second triangle, do we have 3 sides and an angle going on? No. What do we have now?
Opposite and adjacent.
Yeah, good.
There's not opposite and adjacent.
Side opposite angle, yep. And side opposite angle, yep. So that's a sine rule, isn't it? For this one, would you use sine rule for a length or for a
length?
Yeah. Sine rule for a length. Again, it's just like, a over sine of a. Just showing you some examples. Just certain ways that you kind of use. So in order for me to work this out, which rule to use, I've got to have labelled the unknown. So I have to have labelled X, or I have to have labelled in theta, whichever thing is the unknown, or else I have trouble working it out. Sine rule for length, because we have side opposite angle, side opposite angle, if you want to make that note as well. That's why I've tended to put these two lessons together, because you better combine. You've already had exposure to these rules to begin with, so you don't need an intro to them. You just need to review them and remember how do you work out which one to use, because they don't tell you most of the time. There are proofs for these theorems, but I thought I'll just show them to you, and if we get time at the end of the unit, I'll do the proof with you.
You don't have a nice video?
No, I just have a little worksheet that use SOHCAHTOA and Pythagoras to prove it, weirdly enough. Just strange. Use right angle trig to prove a non-right angle trig formula. And what you end up doing is, to prove it, you have to kind of take a triangle like this and cut it down the middle to form two different right angle triangles, and that's how you end up using SOHCAHTOA and Pythagoras to prove it in the end. But rather than you have to do that all by yourself, someone came up with a general rule and they put it in your booklet for you. And then we do some practice ones on the back. So now we're just doing some practice. This is where you probably want to get your calculators going. So we're going to use them. So you might recognize these triangles. They might have been similar to what we had on the previous page. Which formula do you use for this one again?
Cosine.
Cosine for a side, yep. So if you're like me, you could forget to do the square root in the end if you kind of just work out b squared plus c squared minus 2bc cos a. So I go straight to taking the square root. So x equals, I tend to do a big square root. It's going to have a fair bit of stuff underneath there. That's my way. If you have another way and it works, that's fine. B squared plus c squared, doesn't matter which order you put it. You could put 18 squared plus 20 squared, 20 squared plus 18 squared. Adding doesn't matter about the order. 18 squared plus 20 squared minus 2bc. So just times them all together. So again, the order's not important there. And as I said, what's important is the angle. You just have to make sure, imagine they gave you two angles in the triangle. You just have to make sure that the angle used is the one opposite the unknown side. Cos 54. And an examiner might not like the fact that the square root didn't go all the way when you're working out. Because technically, that would mean 18 squared plus 20 squared minus 20, 18, 20, and then that answer square rooted, and then times cos 54. So just make sure you do stuff like that. And then it goes into the calculator just like that, which is brilliant. Just like that. Yeah. And remember, we write the unrounded answer first, just to be on the safe side, and then round your answer. Yeah, so anyone need to borrow a calculator? You all got a calculator? Anyone want to borrow? Yep. Okay. I've already done it. You're just patiently waiting. Okay, so what did you get as an unrounded answer?
For that one?
Yeah, for this one.
343, sorry.
343 dot dot dot.
So,
Okay.
Meters.
Meters, yeah. Good. Units are biggie. Again, you're protecting yourself by writing a bit of an unrounded answer, because who knows, there might be a part B or a C that requires the unrounded answer to be subbed in at some point. So good thing to write out an unrounded answer before you round. The second one, did we use sine rule or cosine rule? Sine. For a length or for an angle?
for
The length, yeah. So for me, I just personally find it a bit easier putting the unknown in the numerator. That's your choice. You can go through that. Like if you tend to use cross multiply a lot, sometimes it doesn't matter. Like if your x is down here instead, if you're going to solve by cross multiply, it doesn't matter the fact that the x was the denominator. And then that kind of thing. Some people might want to go straight to the rearranged, that's also okay. So long as you don't make a big deal doing that, you're fine. So get rearranged. As Bella would point out, we just multiply by sine 53, multiply both sides by sine 53. And then what's our unrounded answer?
And for small round, 9.7406.
Good. And the 3 6 weeks? Good. What units is that?
Centimeters.
Yeah, centimeters. So make sure in your topic assignments you're always, as I said, writing the unrounded followed by the rounded, because they'll want in the later parts, they'll want the unrounded answer to be subbed in. If it was just a single question, it's still worth doing too, just in case you made some weird boo-boo in rounding. If you had your unrounded answer, they might overlook it. And your unit. Oh, so you guys are just going ahead and trying it? Perfect. I'll stop talking while you try. Let's leave that and we'll get some answers soon. The cosine rule one at the end is a bit tricky. Just remember that the thing that has to be in the minus a squared section has to be the length that's opposite the angle. The length that's opposite the unknown angle has to be in the a squared section. Because it's a equals, so a and side a and angle a should be opposite each other. So the side opposite the unknown angle should be in the minus a squared section. What did you get for your unrounded answer for this one? Or do you have the unrounded answer?
30.02704165.
07?
02704.
704. Oh, and the 3 6 bigs.
Oh, 30.
Yeah, 30.0. And what's our units? Yeah, 30. Let me know if you disagree with any of that. My answers are somewhere, but I'm just...
This is 30.0. We have to put 30.0.
If you just write 30, then you're only rounded to 266. So 30.0
Okay.
is 366, yes. That's correct. It's a good point. Good question. Anyone have an answer for the angle from the cosine rule?
No.
Yes, Paige. Yes, you get it.
pictures. Thank you.
So if you remember how to make the nice fractions, alpha y equals. Alpha y. That helps. Like if you kind of don't make a nice fraction, if you just did 8 squared plus 9 squared minus 7 squared divided by 2, 8, 9, there'll be that nice potentially. So using the alpha y equals to make a nice fraction is really important. Same with here. Here it's not such a big deal, but it's good to be in the habit. So this one it definitely can affect your answer if you don't use the fraction. You can get a bad maths problem. You probably can't see, like this mean, there's actually it's the bottom right corner is where she's actually got some of the special triangles are in there. But it's just so small I didn't realize how tiny it would be. So that's the link to the trig, and it's the Brazilian soap opera style. Okay, how about an answer, unrounded answer for the angle over here?
48.18.
And using this?
48.2 degrees.
Why did I not get it?
Good different answer. Did you use the nice little fraction button? Alpha y
Oh, I'm
equals?
so stupid. I didn't even do that.
Cos minus 1?
Yes.
Yeah, and that's so common. So that's why when I find the cosine rule, I don't mind so much with the sine rule. Sometimes with the sine rule, I put it in not rearranged yet. But with the cosine rule, I tend to go straight to the rearranged version because it's very easy to forget those ones. To do the square root for the length, or to do cos minus 1.
Oh, I should have asked how mine was though.
He was.
Hmm?
Pretty great at this.
Okay, we're on the next page. Next page. Okay, so something that
Study them.
something you might not be so familiar with is the ambiguous case of the sine rule. The ambiguous case of the sine rule, it's pretty easy to apply. You just have to be aware of it. It can be forgotten about. Like maybe you might not realize, oh, there's 2 answers to this question. I didn't realize that. I forgot. What does ir mean? What does it mean? When something is ambiguous. When something is ambiguous, it can mean more than one thing. Exactly. Do you tend to see the word ambiguous more so in English? You find? Yeah. You don't see it anyway?
Yeah, I see them trying.
So, what does the word ambiguous mean? It means it can mean more than one thing. So, you might have heard it. You might have heard it in English class in the past before. Ambiguous, the word ambiguous. So, the word ambiguous means it can mean more than one thing. Like, I remember doing like little grammar exercises where there were ambiguous sentences, and you had to work out how they were ambiguous. And some of them were quite funny. So, the ambiguous case of the sine rule. So ambiguity is where it can mean more than one thing. So similarly, you can get some triangles that could be drawn in 2 ways. And here's an example of a triangle that could be, this is one way of drawing this triangle. It's got a length of 5 here, length of 8 here, and the angle, 30 degrees, like where is that? Because it's not quite labelled properly, is there. Can anyone see an alternative way drawing this if we've got a length of 8, a length of 5, and all we know is that angle there. Like we don't know exactly those 2 angles. It's an alternative way of looking at this.
Can you just like flip it around? Like I don't know what you mean.
I suppose you could. That is one way. I want to draw it again. Okay, I'll show you what it means. I want to draw a length of 8. I want a length of 8 still, so I want the lengths that we've got to be the same. I want an angle of 30 degrees here. Can't change. That's a little clue.
Oh, so maybe you could just make 5 the bottom one.
Yeah, that's one way.
You can just say no to it.
Actually, yeah, that would give us an alternative way of drawing it. We had 5 on the bottom, kind of 5 along here.
Well, you know what? I run out of guesses.
Wait, what?
Exactly.
Aren't you just flipping?
Why are these two on my brain?
That would not work.
So, another thing, it's going to be hard to split, at least you see on the video, but imagine this is a kind of a pendulum.
A who?
Do you see how a pendulum can sort of swing?
Oh, that changes the angle.
Yeah, but notice there's nothing here saying what the angle is.
Wait,
So,
so
oh, the only rule is that has to be 30.
what?
It's possible, yeah. So long as this length is 5. The only thing, then it wouldn't be 5 anymore, would it?
No.
Because a hypotenuse has to be longer than a leg. But that's a good way of thinking of it. Yeah.
But if you split your pendulum, you're still changing the angle.
How about Mr. Leonard just tells us the
Ah,
answer?
but no one's saying what that angle is.
But you still
We don't
changing it,
know.
whether we know or not.
Yeah, it's still an angle. So what if we swung it? What if we swung it so that it,
Yeah, I'm not
that it
following.
was like that
So
instead?
then it changes both angles.
An isosceles triangle. So it would be kind of more so going down like this.
But wouldn't that change the length? Is this an example?
That's a good point. It'll change this length here.
I don't want
It'll
to
be
go
shorter,
with those
wouldn't it?
But wouldn't
teachers.
it change 5 as well? Wouldn't 5
Oh, even if you're changing that, you
It's
still
an
have
isosceles.
everything they give you. You still have your 8 and your 30, that's why it works.
You still have your 8, 5, and 30, don't you?
But why would you want to change
Why would you want to do that?
What's the reason?
They're not
maybe-
similar.
Because
But
there
you
might...
didn't change the BC.
It is a completely different triangle. Because quite often in these kind of problems, notice what we tend to give you. We tend to the only thing we tend to give you is 2 sides and an angle, don't we? Or an angle, side. So, imagine the unknown was the bottom length. So imagine the unknown was a bottom length. We could have 2 ways of looking at it. It could be a long length on the bottom, or it could be a short length on the bottom. Or, notice we've got 2 sides, we've got 1 angle. If it was a sine rule, we'd need to know this other side here, wouldn't we?
We're gonna do our cast for the gap together. She really can't tell you about it.
Okay, let's not have any extra conversation because this is hard enough. So imagine that's the unknown angle there.
Yeah.
So that would be, because remember with sine rule we have side, opposite angle, side, opposite angle. So notice that the angle, it could be this one. You could draw the triangle this way, the original way, or you could draw it this way.
Why?
Because the only info they've given us is that, and that.
Wait,
And-
but what would a
But
triangle? Why do you need to draw a new one that looks the same?
It looks the same, but notice that this length is shorter than this length is.
No, but then when they get asked in an exam, they would just say, can you draw this triangle in an alternative way? Oh no, this is just you just trying to tell us something.
Yeah, it's me just trying to tell you something, that's all.
How is that still theta though? How is it still?
Yeah, it's a different measure. Notice that one's acute, and what kind of angle is this one? Obtuse, yep.
So what would be like?
So it's not theta, it's like theta 2.
Yeah, yep, it's like theta or theta dash or something, like, this is a case where, imagine it was a sine rule problem. Imagine we wanted you to find angle C. There would actually be 2 answers. There'd be the answer using this version of the triangle. There'd be an answer using this version of the triangle.
But then that's not the same triangle.
Yeah, exactly, because that length is shorter than that length, isn't it? Yeah. And that angle is bigger than that angle.
The situation is ambiguous.
Yeah, the situation is ambiguous, yep. Because of the restricted information, the way they gave us the 2 sides and the angle, left it ambiguous. The ambiguous case of the sine rule doesn't always happen every time it's a sine rule. It's only when it's a situation like this, where it's possible that this little side could swing and go that way instead. Confused? Yeah, I'll be. It's always confusing and frustrating when people first see it.
It's not that it's like angering.
Angering?
It's like draw an alternative way to draw the triangle, but you just drew a completely different triangle.
Oh, imagine if the question was a triangle with side C is 8, side B is 5, and angle B is 30. Exactly. If that made it a bit more clearer. Yeah, then it kind of makes more sense then, does it? Yeah. So sorry, imagine the question was like that instead. I get you. So it's more so if you just knew that side C was this, side B was this, and side angle B was that. What's two ways to draw it? In a sine rule problem, sometimes if they're nice to you, they might say find two answers for angle C. If they're nice to you. But they can expect that you just automatically realise there's meant to be two answers for one like this. So there are only certain times when the ambiguous case occurs, and I've mentioned that one down the bottom. Notice that it has to be kind of two sides, so that one of the ways that the ambiguous case can occur is when you've got two sides and the angle they give you is not the included one. So they give you two sides and a non-included angle. So non-included meaning not the angle that's in between them. So when they give you two sides and a non-included angle, plus another condition must be there to satisfy it, plus the shortest side has to be opposite that angle there, the little 30-degree angle. Yeah, it's confusing.
Doing in one ear and good on the other, like I can't even process.
Yeah, normally I would need to be given quite a few examples, a few goes at this kind of thing.
Just to make sure I'm just not.
Yeah, it's always frustrating actually for the ambiguous case of the sine rule. It's a strange one. We could say the length of 5 could swing like a pendulum. Sometimes people say swing like a pendulum.
And this pendulum told like this one line.
To form the second triangle. Like, because they haven't told us exactly what angle C is equal to, it means that this length here, the 5, is free to swing that way. It's still a length of 5 if you make it an isosceles triangle. And then instead the triangle would look like this instead. Because they haven't said that this length BC is a certain length. So it could be shorter, it could be longer, we don't know. So that's why it's an ambiguous case. It's been left open to two possible answers. So,
The what?
to form the second triangle.
Look at it says certain.
It does, yeah. Second triangle, yeah, second triangle. The fact that there is an alternative way of drawing the triangle means that the situation is ambiguous. Well, that's it already. I think that side is ambiguous. So, what I try to say, what do you notice about the relationship between the two versions of angle C? So here is the first version of angle C. Here is the second version of angle C. Yeah, one's acute and one's obtuse. Good. That's a good point. So let's write that. One is acute and one is obtuse.
So maybe I should draw the background.
They yeah, word and it means like that word and like
Yeah. There is something else. Yep.
that word, the supplementary. That word means they end up to make 180.
Yeah, totally.
That's the word.
Yeah. Supplementary good memory.
Yeah, the supplementary.
Yeah. That's a very good way of describing it. The two angles are actually supplementary, meaning they add to 180.
So why should we add to?
Because if
Yeah.
it
And then what's
comes to
complementary?
these, it'll be the other angle in that triangle.
Yeah. So that one's
And
equal to that,
make
which means this one here.
like because
Oh yes, 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 yes.
yeah, she's got a little pointer thing.
Yeah. So what you talk, Calvina, and I'll put the pointer.
Yeah.
Which angles then?
So if this angle, if it's isosceles, if that little angle must be equal to that one because it's an isosceles triangle here, and therefore this angle is actually that one there. Yeah. Supplementary. Yep.
You're right.
Yeah. That's a good point. That's a very good point.
Like that's worth it. Start from your phone.
Supplementary, which means they add to 180 degrees. That's copying the test. So what you tend to do is you tend to use the sine rule to find the angle, just the regular way. To find the second answer for the angle, because they add to 180, you just do 180 minus what you got. Yeah. So what you do is to solve something like that, to find the two answers for your angles, you just use the sine rule as normal to find the unknown angle. And then once you've imagined that was 62 degrees, to find the other answer.
And you subtract it from 180.
Yeah, 180 minus 62 to find the. So that gives you the acute answer. The sine rule will give you the acute answer, which is like, by the acute answer, what do I mean by that? I'll try to show you. The sine rule will give you the answer for this version of the triangle. So yeah, so to find the other one, just do 180 minus that answer to get the other answer.
Like, can you just go up in the triangle?
Yeah, sure. Yeah, you want to draw the triangle. There you go.
I just want to work on my EE. Me too. I just need to sit down for a good hour and rip it apart, you know?
Okay. I haven't finished for like 10 years.
What?
It's going to be such a relief when you hand it
I
in.
have to, I know, but I have to and make sure that each paragraph relates back to my question. And the chapter, because he basically like, you didn't answer your question. So I have to think it over and read this like 14 pages and see where I can insert this. Just that's mine. Like 2,000 words.
So, as we mentioned before, this is something we mentioned already. So for the ambiguous case of the sine rule to apply, we need two sides and a non-included angle. What do I mean by that? Like two sides and not that angle. So not that angle. So not the one that's in between the two sides. It has to be one of the other ones. Yeah, so two sides and a non-included angle. So imagine 4, 7. Has to be one of the other two angles, like either that one or that one. Can't be the included angle. So two sides and a non-included angle. And on top of that,
a non-included angle.
Yeah, two sides. Has to be two sides. If they give you that angle, notice how that fixes a triangle. If you did have the included angle, then the triangle's locked in position, isn't it? You can't. There's no ambiguous case because you've got that one. This thing can't swing that way anymore.
Mm-hmm.
So if you do have the included angle, notice it's not ambiguous anymore. So you need two sides and a non-included angle, because as soon as I give you the included angle, then the triangle's already set. You can't draw it two different ways. Two sides and a non-included angle, so either that one or that one. And there's another thing that has to apply. I'll just let you write that first. I'll get rid of all those pictures. Two sides and a non-included angle. And I have to make sure I write this properly. The side opposite the given acute angle must be the shorter of the two given sides. So the side opposite. I have to make sure I word this properly. The side opposite the given acute angle, because it's going to be acute because sort of see it's going to be that little one there or that little one there. But the side opposite the acute given angle has to be the shorter of the two sides. Side opposite the acute given angle must be the shorter of the two given sides. Okay, so what on earth do I mean by that? So two sides and a non-included angle. So as soon as they give you two sides and an included angle, you know the case is not ambiguous anymore. That the side on top of that can't just be two. It can't be. I'll show you what it can't be. It can't be that. It can't be like that. Because notice when it's like that, if I gave you that angle and I set it in stone, notice that this side can't swing anymore. because that it's been locked in because that angle's been put there.
Could the other side swing?
Ah, but that one's longer. It's got to swing down there, isn't it? And it's not a triangle anymore. As in this angle wouldn't be there anymore.
But like, for that
That's a
could
good
that
point.
could swing and it would still be longer.
Ah, yeah, but imagine this one we said had to be 20 degrees, for
I
example.
know, but like if it wasn't 20 degrees and it swung.
If it wasn't 20 degrees? Oh. And then we wouldn't have given you that angle. Sorry, what were you saying? Can you say it again, Grace? Never mind. It is getting confusing, isn't it? So I'll show you what it has to be. It has to be two sides and a non-included angle, and the side, that included angle, has to be opposite the shorter of the given sides.
But like, okay, if you go back up to the 5 thing and you swing it, it's gonna be longer than the bottom.
But we swing it so that it's it doesn't go.
I get you. Yep.
Yeah, so, but that's a good point because some people might be wondering about that. Grace was pointing out that say if you swung it down this way, then it's going to be longer.
You swing it
The-
so that
So that it's not, so that it does fit. It's not hanging down there like that, yeah. It is confusing as.
I can explain these things again. The side opposite, like how do you know that's the acute angle? Like both of the angles are acute. Like,
Yeah, exactly. Both angles are acute. But if I gave you the angle, the acute angle opposite the longest given side, then notice, so I'll show you if I do that.
but basically, I think it's where you're word and confusing. Basically, the acute angle that we need is the one across the shorter side.
Yeah, totally. Yeah, so you can rewrite it like that. If that grammar is annoying, then write it when you're aware. So if I gave you that angle instead, if I said that's 20 degrees, it's no longer ambiguous because there's no way you can swing this length of 7 and get another, like if you swing it down here, then you've lost that 20 degree angle, haven't you? So that's how it's ambiguous. And I'll let you know there is an example on your topic assignment where there is an ambiguous case. So that's why I wanted to make sure to show you an ambiguous case.
She doesn't know.
No, no due date or anything now. You can start, you can make a start on it if you want. Because now, like, a lot of it is, do you remember the area formula?
Formula.
Yeah, the area formula is probably pretty good with too. Like half, area equals half AB sine C. Some of it's using that. And A and B, you have to have the included angle, as you see. We can do some more area formula stuff now. So that was plenty to take in for today.